Good morning. So I think we're going to start soon, and this is not an official part of the program, so we don't need to be very official. We can be all among friends, and if you want, I have been encouraging people to sit close to each other so that we don't feel like we're all spread out. I want to say before I start that we made some handouts of the presentation. There's enough copies for every person. So if you didn't find a handout, there's some in the first row. And it would be great for you to have the handout because this session is meant to give you the basis to understand the sessions in the conference. So I would encourage everyone to take notes, circle things in the slides, make sure that you get what you need out of this session. So it is a very informal session, and you can ask any questions that you ever wanted to ask, and maybe you were afraid of asking. And so when we finish here, hopefully we have an understanding especially of the things they talk about in the medical sessions, the concepts, the words, so that we can understand the discussions later. And I think, yes, I have Dr. Shaw who's walking in, and he is one of our very distinguished speakers for the medical sessions. So I have asked him to come to this session so that we can ask him questions if we have questions. And also, he can check what I say, because I am not a doctor. So if I'm saying something wrong, he's allowed to raise his flag and tell me that maybe that's not good what I'm saying and explain, okay? So I think we should get started. Wait a minute. So I wanted to start by telling you the goals of this session. So the goals are to help you navigate the conference, to help you set goals for yourself for the conference. We are here not because of our own selves, but each of us is here representing a group of people that are back home. So we should have goals. We should know why we're here, what we want to accomplish, and be very deliberate about what we're going to accomplish during the conference. So in this session, we'll set the goals that each of us want for the conference. And then the other piece, as I was saying, to provide you the background of the things, the issues and topics that they will talk about in the medical session so that we can actually understand what they talk about. Because how many people are here for the first time? Very good. A lot of people are new, so welcome. This can be a little bit of an intimidating conference because it is the very scientific discussion. And there's about 120 people here, so I think that now that we all here will know each other, it'll be a little bit easier to make friends and network later on. So that's the goals of the session. I will start by telling you a little bit about what is CML Horizons for those of you that are new. So this conference started for the first time in 2002. It was a conference that Novartis started. It was called New Horizons. And in 2002, which was 1 year after Gleevec came out, they brought together 25 people that were advocates for CML and GIST. I was there, and maybe all of you have met Jan and Giora. They were both there. We came together in Switzerland for 2 days to discuss topics of common interest in CML. And subsequently, Novartis every year organized this New Horizons conference. It was both CML and GIST advocates until 2010. And then in 2010, they decided that they would give the conference to the advocates community. And so they talked to the group there was already formed a steering committee of the conference from some advocates. And then after 2010, the conference has been driven by advocates. We went from having one company support the conference to having many companies support the conference. So we renamed it CML Horizons. And this year is supported by Novartis, by Bristol Myers Squibb, Pfizer, Ariad, Leukemia and Lymphoma Society, and the International CML Foundation. So we're very grateful to all the sponsors of the conference, and I'm glad that the community is carrying on this conference. So I think everybody knows that the CML Advocates Network is a network of 87 organizations from 67 countries. And during the 2005 New Horizons conference, 4 advocates that were here decided to start this network called CML Advocates. And the original reason was that, you know, it was the 4th time we were getting together. We come like we come now. We talk to each other. We spend 2 or 3 days together. And then we would go to our countries, and we would never talk to each other again. So the main central idea of forming the CML Advocates Network was to continue to network after the conference, in between each conference. So the people that were the founders of the CML Advocates Network were Jan and Giora, and Jana, who is in the next door session, and Sandy Crane from UK. And now the CML Advocates Network is hosted by the Leukemia Patient Advocate Foundation, which is a Swiss-based organization. And like I said, we're very proud that every year we have more organizations joining. There's 87 of us organizations. And it's managed now by 3 of the founders, 5 regional representatives, and 1 coordinator. So I am actually the representative for Latin America in the steering committee of the CML Advocates Network. The CML Advocate Network has 4 goals today. One is to provide a worldwide web directory of CML organizations. So if you know of other CML organizations that are out there and they're not members, that you should encourage them to register as members. We want to stimulate collaboration and best practice sharing, which is a lot of what we're doing here. We want to grow the capacity of the advocacy organizations and to provide educational materials on CML. So this is what the CML Advocates Network is doing. So this is very important, I think. Who is here? So there's 93 delegates, and the delegates are the ones that have the yellow lanyard. So all of us, most of us here are delegates, and 23 of us are new for here. So if you're new and you saw a lot of people raise their hands, you're not the only one. There's 22 people that represent pharmaceutical companies, and they have the blue. You will see that this thing is blue. And this, I think, is very important to distinguish so you know who you're talking with. And there's 11 speakers that have a red lanyard, okay? So here's the part where we need to figure out why are we here, other than because either Baija or me or somebody pushed you to register and make sure you came. So does anybody want to share a goal that they have while they are here this weekend? Yes? Can you tell us your name, where you're from?
Oh, wow. Hello. Hi, I'm Victoria Goldsmith from the UK. I'm here representing leukemia and lymphoma research, and this is the first time that we've had any involvement at all with the conference. I'm really excited to be here, and our goal is to get to know more about what's happening here and how we can be involved back in the UK with our network of patients.
Wonderful. Welcome.
Thank you.
Who else? Anil.
Hello, I am Anil from India. I'm from Friends of Max. The sole aim to come here is to learn more about advocacy and to find out newer ideas, to have larger groups, satisfied groups, and I think together we can learn and share. So the whole idea is to come here and learn more about advocacy, newer ideas.
Right. Very good. Anybody else wants to share any goals that they have to come here? Yes, or Boris.
Okay, hello everybody. I'm from Georgia. I'm a first time here, as others many. The goal is just to learn the advocates in reality, how it works. I'm sure that I'm the first time here, but you have more experience than me, and to share the experience, whichever you have, and bring back to home and make people happy.
Very good. Welcome. Anybody else? Oh, yes. Professor.
I am Professor Tayani.
I think you need to turn on.
Yeah. I am Tayani from Pakistan, and my basic goal is to create the awareness about the patient, among the patients, about their diseases and how can it be treated, how can it be subsidized. And here I came just to know the best procedures and process from my colleagues. Thank you.
Very good. Welcome. Anybody else wants to share? My friend Edward.
My name is Lubega Edward from Uganda. The goal to why I'm here is to learn how I can best activate fruitful advocacy in Uganda and involving partners like the government and all other private institutions to come together for a common cause. Edward Lubega from Uganda.
Very good. So I think the best way to achieve these goals that we have is to make a plan. And I think that this is the time we're just about to start the conference to really make a plan for ourselves of what are we going to achieve specifically. So these are some ideas that I had. So one goal that I think many people have here is to learn about advances in the treatment of CML. And so we have the medical sessions for that. We want to learn about each other's experiences. And I have to say, this is the first year we don't have a session of best practice sharing. If you've been here before, other years, we had a session where maybe 6 or 8 people would present some best practice in their country. We don't have that. So the way to learn from others, other than meeting each other and talking about what you do, is to look at the posters. Really spend time in each poster, and when you see something that interests you, then hopefully the people that are presenting posters are standing somewhere next to their poster, and you can talk to them about their project. So I think that's very important. We want to learn about advocacy, and there'll be some advocacy sessions. One thing that I think is very important is this is a great opportunity to meet industry representatives and speakers. So like I was saying, there are, I think I said 22 people from pharma companies here. And this is an opportunity for you to get to meet them, to tell them about your country, to tell them about your members, the members of your group, to ask them if their drugs are in your country, why they are, why they're not. If you have a project that you think that could be interesting for the company to sponsor, you can tell them about your project. And if they're not the person that exactly deals with your country, you can ask them for their card, and then when they come back home, they will send you the contact of the person that deals with your country in the company. This has to be a very important goal because I think that not too many people from the big pharma companies get the opportunity to meet with patients and with advocates from our countries. So I think that that's a very important part. And then I think, because people that work with me know that I don't believe too much in just playing and not working, I do believe that you have an obligation to produce a report for your members. What you learned, what you saw, some ideas, and present that to your group when you come back, because you're here representing them. So I think that these are some of good goals that we can think for ourselves. And as we go along, you can write down your own goals, or I believe that during the conference, if you hear something interesting, just write it down for yourself, take some good notes. Anyway, the conference is structured in 8 sessions, not counting this one. So there's 4 medical sessions and 4 advocacy sessions. In the medical sessions, there will be 1 session about updates in CML treatment. So talk about the new updates, what the researchers are learning these days about treatment of CML. There's another session on CML in real life, and that should be very interesting for all of us. There's a session specifically on generics and copy drugs in CML, because I don't like, but it says the new realities, generics and copy drugs. And I think it says the new realities because this problem has finally come to Europe. But this has been a reality in all our countries for many years. So I think we're happy that now the world is paying attention to the issue of the copies and the quality control and the generics. And then there's going to be a session about the conversation that everybody's having about treatment-free remission. So can we stop the drug and still stay in remission? And, or is it possible to eradicate CML, to actually cure the CML? So there will be a session on that. That should be very interesting. And then in the advocacy sessions, the first session of this afternoon, which is when we start the conference, we'll have each region representative will present the region. What are the challenges in our region? What are we doing in our regions? So that everybody can get to know a little bit more about each other's region. Then we will have a session on the use of social media, and it will be a hands-on session. So this will happen on Saturday, and if you have computers or laptops or iPads or any device, it would be good to bring it to that session, because you'll get to do some hands-on developing of some social media tools. And you can also see that we have a Twitter feed during the conference. So some people will be tweeting, and the tweets that people are doing will show up in the screen in the middle. So how many of you tweet? Yeah, not too many. So we're learning maybe we'll all sign up for Twitter during the social media session, and then we can practice and tweet, okay? This could be a goal that we can have. And then there is a session about developing and implementing an advocacy strategy, so that should be important, I think, for all of us. And there's the last session is called Supporting People Living with CML, which has to do more with the caregivers, and some of us are caregivers too. So that's how the conference is structured. And then I just want to tell you, if you have questions about logistics, I think everybody met the people at Liberty. They're in the front of the hotel, and they're being extremely helpful. And I think everybody met Nicole from CML Advocates Network. Everybody knows who Nicole is. So for anything else, you can go to Nicole, or anyone in the steering committee is happy to answer questions and solve problems that you might have, okay? And this is my sidekick over here, Marisabel from Venezuela, who is being my emotional support when I'm giving my presentation, right? And she is a wonderful advocate that has been coming here for many, many years. So she is a great person to ask if you want to know anything about this conference. Marisabel can answer your questions. So before we go into the medical stuff, does anybody have any questions? We're ready? We're ready. We're very confident that after today we're going to understand a lot about CML that maybe we didn't understand before, okay? So I think as I was thinking about this session, I was thinking, does anybody really understand what is this BCR-ABL? That you're going to hear a lot talk about BCR-ABL, and I wanted to make sure that all of us understand in very simple terms what is this BCR-ABL. So I think we all know that CML is a type of cancer that starts in the bone marrow. And when this cancer starts, there are two chromosomes, the 9 and the 22, that swap apart, right? So the break in the chromosome 9 is called ABL, and the break in the chromosome 22 is called BCR. So this new chromosome, that is what's called the Philadelphia chromosome, has this part that's called the BCR-ABL gene. So you will hear a lot in the medical session that people talk about the levels of BCR-ABL, which means how many cells in the patient have this BCR-ABL gene, okay? And people living with CML carry this BCR-ABL gene. Yes? We get that? And so this BCR-ABL gene is a protein. It's a type of protein that's called tyrosine kinase. So this is the other term that we hear so much when we talk about TKIs, these tyrosine kinase inhibitors, which is these types of drugs. And this is where this is coming from. So this is the part of the chromosome that actually, when it's formed, it means that somebody has CML. Does that everybody follow that? Yes? A little? Okay, so we will remember when we hear people talking about BCR-ABL. So in CML, in treatment of CML these days, it's all about, can we get rid of all the cells that have this switch in the gene? So if we get rid of all these cells, then there's no more CML. And that's why you're going to hear a lot of conversation about how can we make the BCR-ABL number very, very, very low. So there's very, very, very few cells that have this gene. Yeah? So we'll remember that. It's in your little cheat sheet that you have over there. So I'm okay so far, Dr. Shaw, you think? So far, he's not so sure. He's not so sure. You can come and take over any time that you think that this is a disaster, okay? I wanted to say, because I know a lot of questions that patients ask is this, what causes CML, and is it hereditary, and can I give it to my child if I have a child, right? So I think that, I'm sure Dr. Shaw knows a lot about what causes CML, but I don't so much. But here's what I wanted to say that we know. It is not hereditary, so we don't pass it on to our children. There's no way to pass it on to your children. And it is not contagious, so being close to a person with CML will not give us CML. And those are two things that a lot of people in your country, your members of your group, are always concerned. So I think it's important for you to know this. So when they ask, you say, I went to this conference and they told me it is not contagious and it is not hereditary. So we are not going to catch CML from somebody else, okay? I also wanted to say, if you look at the books and in the internet, it says that the average age of diagnosis of CML is 65 years old. But I think we know in our countries, people with CML are a lot younger. So I think that in a lot of countries in Asia and in Africa, the average age of diagnosis is more like 38 years old. And it happens more in men than in women. So I think that those are some of the basics of CML. Okay, now we're going back to this tyrosine kinase and talk about what are these TKIs. So we said that CML is caused by this gene in the cells that's called the BCR-ABL gene that is a tyrosine kinase. So this type of drugs called tyrosine kinase inhibitors, they inhibit, they prevent, they stop this BCR-ABL gene. So that's why we call them TKIs, because it's very difficult to pronounce this name of the tyrosine kinase. And it's different from chemotherapy because chemotherapy attacks all the cells, the ones that have the problem and the ones that don't. But this type of drugs are these targeted therapies, so they don't make you so sick because they only attack the bad cells, right? Yes, I'm okay. Okay, great. So this is what we talk about a lot about TKIs. The first ever TKI that was developed for CML was the Gleevec. And that's why it was so revolutionary when it came out, because they had not done a drug like this before. And so I think that it's difficult to remember all these drugs and all these names. So these handouts that I gave you have these names, and you can go back to them every time you hear the name, because it is a little bit difficult to remember. They have a drug name, then they have a brand name, and then there's a company that makes them. So we know that Gleevec is made by Novartis, but the drug name is imatinib. So Gleevec and imatinib, same thing. Sprycel is the BMS drug, and is also called dasatinib. So then you have nilotinib, which is Tasigna, which is a Novartis drug. You have bosutinib, that's called Bosulif, that's made by Pfizer. And then you have ponatinib, that's made by, it is called, the name of ponatinib, the brand name is Iclusig, and is made by Ariad. So this is very difficult to remember for all of us, but now you have it in this sheet, and you will remember, you have to try to remember because people talk all the time about dasatinib or nilotinib, and it would be good to know immediately what drug we're talking about and what company makes the drug. So that's a little bit important. If you're going to try to remember something, this is a thing to try to learn for us. And now that Gleevec is losing the patent, so the patent is expiring. So now there's a lot of companies making different types of imatinib. And so those have other brand names, right? So we know Vinat, for instance, is a brand name of imatinib that is not the Gleevec one. So, but it's the same drug. So many of you know in your countries what these names of these drugs are. Okay. Then I always also wanted to talk about first-generation TKI and second-generation TKI, because you will hear the experts talk about this. People talk very quickly, first generation, second generation, and I want to make sure everybody knows what they're talking about. So because Gleevec came out first, people sometimes refer to Gleevec as first-generation TKI. And then some years went by, and maybe 5 years later, two drugs came more or less at the same time, the Tasigna and the Sprycel. And so a lot of people refer to these drugs as second-generation TKIs. But this is the way that people talk about it. There is nothing except that the fact that they came second, they came later. And now some people talk about ponatinib and bosutinib as third generation because they came sort of later. So I just wanted you to remember, so when you hear people talking about, oh, a second generation TKI, then we know they're probably talking about dasatinib or nilotinib. Okay? Oh, yes, Dr. Shaw.
If I can just make a clarification. So yeah, the way that you have it listed up there is absolutely true. Bosutinib is considered a second generation, actually. The one thing to keep in mind is So imatinib, so first of all, they all end in tinib because it stands for tyrosine kinase inhibitor. So that's why all of these, the name ends in tinib. But imatinib, we've learned, is there are a number of mutations that can cause resistance to imatinib, a large number. The second generation drugs are more potent than imatinib, and there's only a very small number of mutations, maybe only 4 or 5, that can cause resistance to these second generation drugs. And most notably is this one mutation you'll hear more about, this T315I mutation. Though that mutation is not covered by any of the second generation TKIs. And ponatinib, since it has activity even against that mutation, was called a third generation in part for that reason.
Oh, okay, very good. Yes.
Yes, I'm Adam Said from Cameroon. I want to ask a question on TKI. What I understand is TKI prevent production of new ABL-BCR gene, isn't it? And what about which are already inside the blood, those genes which are already inside the.
So you're asking what does the TKI do to the cell that already has that BCR-ABL mutation?
Yes.
So I'm sure Dr. Shah wants to answer that.
Yes, so one of the remarkable things about these drugs is, as you know, when people are first diagnosed, if you look in the bone marrow, you'll see evidence of the Philadelphia chromosome in all the cells almost that one looks at under the microscope. And what happens, and the white count will be very high also, but what these drugs do is, in addition to bringing the white count down to normal, in the most effective cases in the bone marrow, you see disappearance of cells that have the Philadelphia chromosome. So it actually not only prevents new cells from being formed, but it also kills off the cells that are already there.
Thank you. Dr. Shah, would you mind to come to the front? Maybe you should sit here so that people can actually see you, because I can see that we can use your help a lot. I think so. Thank you so much. I was trying to pretend I'm a doctor, but I will not. But I wanted to say that this second generation TKI is not the same as of a second line treatment. These are two different things. Sometimes they're the same thing, but we're not talking about the same thing. So we'll explain that in a minute. So you will hear the experts talk about second generation, third generation, first generation, but you will also hear talk about first line treatment, second line treatment, and that's a different thing. So I want to, we'll talk about it in a minute, but I wanted to make sure that we know, we all understand what is an approved label. Okay, so yes.
Thank you, Pat, for this informative presentation. My name is Ferdinand Mwangura from Kenya. I specifically would like to ask Dr. Shah if, for example, a mutation has been suppressed by first line, and then, okay, a mutation has come up after first line, and then a patient gets to second line, and the mutation goes down. Is there a chance of that mutation ever coming back again while the patient is on second line?
Yeah, so I think the question is, if someone loses response to Gleevec with a specific drug-resistant mutation that is sensitive to a second-line treatment, and then that patient responds, if that patient, and some of those patients do eventually lose response even to the second-line therapy, what we have and others have found is usually there has to be a mutation that is resistant to the second-line therapy that will cause loss of response to the second-line therapy. Now, sometimes that happens on the backbone of the first mutation. So sometimes you may have the Gleevec-resistant mutation plus, for instance, a dasatinib-resistant mutation together. But sometimes you see that resistance. For instance, you may have a patient with an M351T mutation on Gleevec who's treated with dasatinib and then responds, eventually loses response with a T315I mutation by itself. Or you may see that in the same context. It's different for everybody.
Thank you. So I wanted to talk to make sure everybody understands, we all understand what is an approved label, right? So drugs are developed usually by pharmaceutical companies, and then they get tested with the clinical trials. And we're not going to talk too much about clinical trials now, but there's the phase 1, phase 2, phase 3. Then the health authorities, the company presents the data to the health authorities, and the health authorities of each country decide that they see that this drug has efficacy for some disease, so they will approve it. So the health authority of the country said, this drug is approved for CML. But not all the drugs that are approved for CML are approved, like it doesn't say this drug is approved for CML. It's very specific. So these labels might say for adults with this type that have the Philadelphia chromosome, that have CML, or that is only for blast crisis patients or only for chronic phase patients. So these labels are how the drug gets approved is very specific. And not all these TKIs are approved for the same thing exactly, and not all the drugs are approved in the same way for every country. So I think what's important for us to know is that one of the two most important health authorities are the FDA, which is the US health authority, and the European Health Authority, which you call, how do you call the European? EMEA. But each of our health authorities in our countries need to approve the drugs too, also. And many times they look at the approval of the FDA or they look at the European approval to sort of mirror the same approval of the drugs. But one thing that we need to make sure that we are aware as advocates is what drugs are approved in my country and for what. Because, for instance, a lot of drugs at the beginning are not approved for children. And one of the issues we have as advocates from emerging countries is that we have a lot of children with CML, right? So many times, maybe Dr. Shaw will say if this is right, but many times when the drug first gets approved, it gets approved as what is called second-line treatment. So it's only can be given to people that already tried the drug that has been approved for a longer time. And if they fail that drug, then they can use this other drug. So you cannot just use any drug for any patient in any country. And this is why I don't know that we all know the exact approval of each drug today in our country and what does that label say. But that is what this first line, second line means, is different. First line is the drug that gets approved for a patient that is newly diagnosed and hasn't been treated. And second line is a drug that's only approved for people that already tried the first line treatment and now can have failed that treatment, so now can go on to another treatment. Yes? Okay. So I think that that's very important for us to keep in mind for our countries. So what if a drug is not approved in our country? Because in a lot of our countries, all these drugs that we have in that slide where you have dasatinib and nilotinib and bosutinib, and they're not approved in our countries. So when a drug is not approved in a country, that means the health authorities of our country has not given permission for patients to use this drug. So if we are in this country where the drug is not approved and somehow somebody needs it, it is not so easy to give it to the patient because there hasn't been approved, okay? So there are a couple of ways that we can get around that problem. One is a clinical trial. So a clinical trial can be set up in a country, and typically it gets set up to collect data so that then can be presented to the health authorities to actually get the drug registered in the country, right? The other one is compassionate use. We call this compassionate use requests. So we request to the pharmaceutical company, you don't have this drug registered in my country, but this patient needs it, and can you give it on compassionate use? The compassionate use is very regulated by health authorities. It is very complicated, it is very expensive, and so sometimes companies are reluctant to do that because it is a long, complicated process to do. And then in some instances, we can bring drugs in as humanitarian aid, but also we need, in the case of the compassionate use, the clinical trial, and the humanitarian aid, we will need authorization from the health authority of that country to bring that drug that is not registered. So as advocates, we want to know exactly what drugs we have in our country, where are they registered. When you talk to people from pharmaceutical companies here, you can ask them, are you planning to register your drug in my country? Because we are a group, there's 500 of us, we have CML, and probably many of us will need your drug. So this is important for you to know. And I have to say, in a lot of our countries, the regulatory process for a company to actually register the drug is very complicated. And so as advocates, we need to know what is that process, because sometimes we can help get this process a little bit easier to do. But I know that in a lot of our situations, we have patients in our groups that need a drug, and typically it's very difficult to figure out how to get it in because it's not registered in these countries. So if we talk about treating CML in 2014, in general, and I'm sure Dr. Shaw can tell us, but if you have a newly diagnosed patient, you typically give them one of the TKIs that is approved for first-line treatment. And in most of our countries, Gleevec, which is imatinib, is approved for first-line treatment. But it's very different for the nilotinib and dasatinib and all the other newer TKIs. They can be, for instance, Sprycel and Tasigna, the nilotinib and the dasatinib, are approved as first-line treatment in a country like the US. But in India or in other countries, some are not approved for first-line treatment. First line. So if everybody would go to their country, in a lot of the countries it's not. So if I happen to be in that country and I know that dasatinib is a better drug to start treatment than imatinib, we still cannot do it because of the way the drug is registered. So companies, many times, they start with this first registration of second line, but then as they have more data, they apply again to the government to allow them to have it registered for first line. So, yes?
Here I have a small doubt. Is it the government who decides, or is it the doctors who decide?
It's between the government and the company. So the company has to apply to the government to approve the drug. And sometimes I don't know if we have any pharma person here, but I think that companies want to have their drugs be first line, so they want more people to be able to use their drugs. And the governments some governments that have situations where the moment they approve the drug, they have a responsibility to give it to the people, are reluctant to approve them in first line. So it's not only from a medical point of view that these decisions are made, it's political and it's economic. So if this other drug is more expensive, we've seen governments, like in the UK, that are very reluctant to approve all these drugs at first line because they don't want to have to pay because they're more expensive than the other drug. So this is an area that we as advocates can try to influence.
No, but at times, if the patient has some idea, and a doctor tells him that, look, here is a drug which is, say, Tasigna, which is so because I know many patients in India now who started with Tasigna.
Right.
So who was the person who informed, or who was the person who took this decision? It is just a doctor.
So the researchers and the key opinion leaders, as we are going to learn in the medical sessions, do a lot of clinical trials comparing this drug to this drug. Which one is better? Which one has a deeper response? Which one acts faster? And I think that what we're going to see later on is that some of these second-generation drugs are stronger than Gleevec.
Yes.
And so
based on the
there's
studies,
a theory that says that they're better. So if you have to start, and I don't know what is Dr. Shaw's opinion about, do you start with one of these second-generation TKIs if they're all first line, or you still start with imatinib and then move to the other?
I think we're going to talk about that, a little bit later. But one other thing to keep in mind in all of this is, with longer follow-up, we're learning more about potentially dangerous side effects of some of these medications, and so that's something else that needs to be incorporated into this. So it's not really so clear, even today, if there is a single drug that is the best drug to use in newly diagnosed patients.
Very correct. Because every doctor has a different opinion. Every doctor. Very correct.
Right. Because, and this is, I think it's interesting to actually keep that in mind when we hear the discussions during the conference that we're going to learn. We are learning as we go along. This is not, CML is a disease that is all the time, new things are being studied, and we come up with different conclusions. And so we are trying to be advocates at a time where, at the same time that the doctors are themselves debating about things, we are trying to figure out how to help our group members. So it is not black and white, and we have to keep that in mind, I think. Okay, how are we doing? We're okay, because it starts a little simple, and now we get a little bit more complicated as we go along. But we are doing great. I think we're doing great. So what is drug resistance? When you see one of these labels, and by the way, if you have a box of one of these drugs and you open that paper that it has inside, that is the label. That tells you exactly what this drug is approved for. And you can read there what the label says. But many of these second-line treatments says that the patient can use it if it's resistant or intolerant to a first-line treatment, right? So what is drug resistance? It's when this TKI, for some reason, stops working. And this is what Dr. Shaw was referring to, right? For some reason, something happened, some other change in the cell, in the chromosome happened, that the drug doesn't work so well anymore. And these are other mutations that happen in the cell. And do you know why these mutations happen? Do you?
So we don't know why some patients lose response, but as Pat mentioned, the most common cause is that we will find drug-resistant mutations. We We think that they probably just arise due to random chance. Every time a cell needs to divide, it needs to faithfully copy all of its DNA, and it never does that with 100% accuracy. And if it happens to introduce a mutation that can cause resistance to the drug, and then a drug is given, the thought is the mutation was probably there before the patient started taking the medication, and cells that have the drug-resistant mutation are not impeded, and so they continue to grow. But we don't know why. And we think it's probably just due to random chance in when you have a disease that has 10 trillion cells or so when people are first diagnosed. You don't have to have a very high rate of mutation development to unfortunately possibly pick up a drug-resistant mutation.
So I think the important thing to know is there's nothing a patient did wrong that is causing a mutation. It is random, is what the doctor says. So I think that's important to keep in mind, because sometimes people can feel guilty, like I did something wrong or what happened when the mutation is there. So this is what's called drug resistance. So the cells get resistant to this drug, and then you need another drug. And then there is drug intolerance, and this has more to do with the side effects. So for whatever reason, some people can tolerate these drugs better than others. It's caused by drugs also interfering with other body functions, not just with the BCR-ABL. Because even though they're a targeted therapy, they do have some effects on some other parts of the body, right? So I think this is more of a subjective concept. So if a patient says they cannot tolerate because they're having some side effects, it's more open to interpretation. Intolerance, you would say?
Yes, so this is an evolving area, because when we did the first studies, for instance, with dasatinib, to be eligible, you had to have disease that was either resistant to imatinib or you had to be intolerant to imatinib. And there was a very strict definition for what comprised intolerance. It had to be significant liver toxicity or skin toxicity. But as time has gone on, we've broadened that definition a lot, because a lot of patients don't have severe toxicities, but they have moderate toxicities, for instance, nausea or muscle cramps, and that having to deal with that on a chronic basis is very difficult. So we are now using a much broader definition, but for the clinical trials, usually it's a very strict definition of intolerance.
I have to say, and this is maybe my opinion, but I think it has also to do with expectations. Because what I see, as I see a lot of people talking about CML and intolerance and side effects, is that people in certain countries have this expectation that they will not have any side effect. Maybe in the US, I think people tend a lot more to expect a life with no problems. And in other countries, people sort of take it more as a part of life to have one thing or the other. So to me, it's a very fluid type of concept. And I don't know what you think also, Gail, you're from LLS, but it seems to me that in some countries, people have an expectation that they can fix every single problem that they have, and then they tend to say that they're intolerant more than in other countries. But that's just my opinion. Okay, so this is important. So we will hear a lot in these sessions about resistance and intolerance. So it's good that we have these concepts and we understand them. Okay, now we go on to this whole topic of monitoring CML, which in the past 2 or 3 years, all of a sudden, we talk a lot about monitoring CML treatment. And monitoring, when people talk about monitoring, they talk about checking how the treatment is doing, how is it working, okay? And because we have so many different drugs to choose from, in theory, is that we want to know how the patient is doing so that we can give the patient the best drug for that patient, right? When there was only one, there was not so much incentive on monitoring because there was just one. But now we have a lot of different choices that we have to make. So we want to know, is the TKI still inhibiting the BCR-ABL, or are these cells becoming resistant? That's what we want to know. And then we want to know how deep this response is. So this whole topic of monitoring, that's what it means. And there are some different methods of monitoring CML, and you know better than me, the blood count. So this is something that every CML patient gets to do their blood count, right? So it measures what is called the hematological response. So when we talk about hematological response to the TKI, we're talking about the blood count. Is the blood count normal or is it not normal, right? Then we also monitor cytogenetics and FISH, which is something also we are familiar with. And this measures the cytogenetic response to the treatment. So this measures the number of cells that have this Philadelphia chromosome. And then there is the PCR that we hear so much about these days. And this measures the molecular response to the treatment. And this is the most sort of sensitive test. Can you explain with your own simple words the difference between cytogenetic and PCR, please?
Yeah, so the cytogenetic test, it's looking largely at the whole chromosome level for the number of cells that have the Philadelphia chromosome. But it only looks in a rather small number of cells. So typically, if you do a bone marrow aspiration, the pathologist will view 20 cells and will look at the chromosomes in each of the 20 cells. And if one of them has the Philadelphia chromosome, he or she will say that there's 1 out of 20. So the sensitivity of that test is limited because if somebody has 1 in 1,000 cells that has the Philadelphia chromosome, you're not going to be able to detect it looking only at 20 cells. The PCR test is a molecular test, and instead of requiring a bone marrow aspiration, it can be done in the blood, it can be done on cells in the blood. And it's much more sensitive, so it can detect 1 in 100,000 cells. And in some ways, if you're familiar with HIV testing and monitoring response to HIV therapy and quantifying that, it's really rather similar, but instead of quantifying HIV, we're just quantifying the specific fusion between BCR and ABL. At this moment, at least I think most of us, so what we've learned from imatinib is if after 12 months you have what's called a complete cytogenetic response, meaning in the bone marrow there's no sign of the Philadelphia chromosome. The outlook at that point, with just continuing, for instance, imatinib therapy, is excellent. Maybe 3% or so of those patients will have problems with their disease down the road. So 97% would be likely to do well. So that remains sort of the minimal level of remission we would like every patient to ideally obtain. The deeper levels of response, when the PCR test becomes undetectable, that of course means that even using our most sensitive tests, we're unable to detect the disease. We don't know for sure whether that means that those patients will do better over the years and decades. They might do a little bit better, but when 96, 97% are likely to do well, at least over the next 6 or 7 years, it's hard to improve upon that in a significant manner. But those are the patients that when they test negative by that PCR test are the ones who are undergoing some of these trial evaluations to see if they can stop treatment. It's in that setting. So that's one reason why this is an area of great interest, because we may be able to interrupt therapy in those patients, and maybe even in patients with lesser degrees of remission, but we're not yet evaluating that. We're only evaluating it in those with the very deepest levels of response.
Yes, Boris.
I have a few questions, but I'll ask later. But while we're approaching the PCR and fish that, I have the question to Dr. Sean that if the PCR, it's PCR, as I know that it's a peripheral blood, yes, and it's not a bone marrow. And if the PCR is available or whatever it's done for the patient, it is still must to do cytogenetic in the fish, or?
No, so that's an excellent question. So if one has access to a good PCR test, in most instances, so in my clinical practice, I'm recommending, following the first bone marrow at diagnosis, I'm recommending very few follow-up bone marrow procedures, because in most cases, patients are responding so well, and you can determine that with the PCR test, that you do not necessarily need to get a bone marrow assessment. But there are some cases where we still do it.
There is still chances to have Philadelphia chromosome, but PCR was, let's say, undetectable or a very low number.
Well, it's so I'll answer that. There's more than one answer to that. We have a sense that a cytogenetic response, a complete cytogenetic response, is approximately equivalent to a 2-log reduction, so a 99% reduction or so.
It's working here.
Okay, I think we're back on. So one important thing to realize about the PCR test, and I had such a case recently, is 1% of all CML patients will have CML, and you can detect the Philadelphia chromosome, but they will have an unusual fusion of their BCR and ABL genes, so that the PCR tests that are offered pretty much throughout the world, they do not include the tools to detect that unusual variant. And so I think it's important to determine when someone is first diagnosed that they actually have, that they're in the 99%, because if you do not determine that then, and the first time you check a PCR is after starting therapy, if they're one of these 1%, it's going to test negative, but it may be a false negative. You know, it may be that even at diagnosis it would have tested negative. It's rare, it's 1%, but it's something that we need to know about.
Thank you.
So no, the way that these are, so yeah, this is getting very technical, but so the BCR and the ABL fusions, the BCR are typically the part that fuses, is typically called either B2 or B3, and it usually fuses to what's called A2 in ABLE, but sometimes it fuses to A3. So these would be the so-called A3 fusions, and studies have shown, like as I said, 1% of CML patients, they still respond to the tyrosine kinase inhibitors, but then this test is completely worthless. The PCR test is worthless in those individuals.
Thank you.
And then you can only follow with the bone marrow. I mean, I do have such a patient.
Thank you.
Just a quick question. It happened in case of, I'm a caretaker. My son was diagnosed 9 years back. I remember very clearly, at one time, the bone marrow test showed the response of 20%. And my doctor suggested that only once this bone marrow will be zero, then only I will go for BCR-ABL test as a procedure. Very correct, no doubt. But within my group, I had people who were doing this BCR-ABL test. So just out of curiosity, I got my son BCR-ABL test done. And surprisingly, the BCR-ABL test results were 0.01. And in the cytogenetic test, that is bone marrow test, it was 20%. How it is possible? The BCR-ABL test and that lab, because I showed them the result of cytogenetic, which was 20%, and their result was 0.01, they did it once again. It was the same, 0.01.
This is this 1%, I think.
Yeah, I think so. I would expect, so I assume that's a very low level. Again, I would have expected it to, if this is one of those 1% of cases, I would have expected to be completely negative, but it might be that they're picking up some low level of something. But yeah, I would tend to believe more the bone marrow cytogenetics. There have been some physicians in the US who've gone around saying you do not need to check a PCR test until the bone marrow. Up until recently, they were going around saying that, but the guidelines changed. But I was always very concerned because, as I've said, there are these patients out there whose disease is never detectable by PCR.
That's interesting, but I think in the reality of a lot of these countries, we have bad cytogenetics, which is a little bit of what perhaps is happening. And I know that Rod had a similar experience with his son too, very similar to that. He was getting fish all the time for many years, and the fish was always slightly high. And when we finally did a PCR, he was an MMR. And so I suspect that the cytogenetics are not done very well, if that's possible.
Yeah, I think that's possible. It's always hard to know when you have, these tests that are telling you different things. It's hard to know which test is erroneous. The good thing is we have 3 tests. So what I like to do is use all 3 in those instances, and hopefully 2 out of the 3 will be more consistent with each other, and then I would probably tend to believe those 2. So I would, do the cytogenetics by looking under the microscope, as well as the FISH, which is a separate test, and the PCR. And if 2 out of those 3 are in agreement, I would tend to believe that result, whatever it is. But it can be a difficult issue to figure out.
Okay, very good. So let's go to the next slide and see what it is. Okay, so we talked a little bit about this, and I wanted to show you some of these letters that you will see in the slides in the conference, in the medical sessions. What is this MMR and CHR? And this is in this table what it means. So we talk about partial, major, and complete response, and the different levels of testing that we talked about. And so you will see if somebody says MCR, that is major cytogenetic response, or CCYR, they call it, for complete cytogenetic response. And we'll let the doctor in a minute, because I have a slide about this log reduction, which is also a little bit complicated to understand. And again, I want to say the doctors are just now agreeing on all these things, debating on all these things, which is what we're going to be listening in the sessions. So what they do this year, then we come next year, maybe the opinion has changed a little bit. And one of the things that I see this year is that people now are not wanting to talk about CMR for complete molecular response, but instead they're saying MR 4.5. And we'll talk in a minute about what that is, because there's a lot of this discussion about the MR 4.5. But this is I want you to have this to try to remember when you see this terminology what it means. So I wanted to say also there's two sort of bodies that put out some guidelines. So Dr. Shaw and all the other key opinion leaders are trying to figure out how to use all these drugs in the best way possible so that people will live with CML for many, many, many years, right? Or that will be cured of CML. So as they do research, they're putting on these guidelines. So one is the ELN, the European Leukemia Network, is one of these bodies that puts out guidelines for doctors, and the NCCN, which is the US body that makes guidelines. And I think those two are pretty similar guidelines. We often talk about the need to have guidelines for emerging countries. Can we really go by the guidelines of the European Leukemia Net? Because of course it talks about a lot of tests, and cost is always a big problem in our countries with that. But it's important for us as advocates to know about these guidelines. The CML Advocates Network has put together a great document that has patient-friendly, the guidelines in a patient-friendly way. And you can see them at the CMLadvocates.net. You can go and download these guidelines in the patient-friendly version. And I think some of the advocates here has helped translate them into some languages. And if you want to volunteer to translate them to your language so that you can have them in your country, you should really talk to Jan or Giora, and they'll be very happy to work with you to get those translations there. Okay? So I don't think that we need to explain too much about each of these, but I want you to know that what the terms come from. So here's now it's the most complicated part, which is the log reduction, but apparently very important. So I will not even try. I will let Dr. Shaw explain to us the log reduction.
Okay. So when we're healthy, we have about 10 to the 12th power cells in our blood system, in our bone marrow and in our blood that are healthy cells. So that is 10 trillion, so not million or billion, but 1 trillion cells. And we think when people are diagnosed with CML that they may have 10 times the normal number of cells in their bone marrow and blood put together, and most of them contain the Philadelphia chromosome. So we think that their disease burden may be as high as 10 trillion cells when they're first diagnosed. And as we talked about, that a complete cytogenetic response is approximately going down to about 5% or so of the original level. So, and 1% is used more or less as an approximation, actually. So one log means a tenfold reduction. So if someone's baseline is arbitrarily called 100%, for instance, a 1 log reduction would just be even though it sounds substantial, you're getting rid of 90%. There still may be as many as 1 trillion cells left. And 2 log, of course, and 3 log you can see further down. Now, the limit of sensitivity, as I mentioned, of the PCR test is it can detect maybe 1 in 100,000 cells. So it's somewhere between 4 and it's somewhere around 5 logs or so that it can detect a disease burden reduction. So after that, somebody, and to be truly cured and have no evidence of disease, you would of course need a 13 log reduction. And so the problem with the PCR test is even in the best labs, its sensitivity is limited. And so part of the reason that we no longer use this term complete molecular response to denote when someone is undetectable by PCR is because if you look in one lab that is very sensitive, it may be at an extremely low level before they test negative. But if you look in another lab that isn't very sensitive, it may be even a 3 log reduction is a complete molecular response in that lab. And so it was important to come up with a standard definition for these clinical trials when people are going to be interrupting therapy. And so the 4.5 log reduction is believed to be a level of sensitivity that should be achieved in most labs. So the most important numbers here to keep in mind, I'd say, are the 1 log, which is 10% level. We want patients to achieve that usually within 3 months after starting TKI therapy. And then the major molecular response, the 3 log reduction you'll hear a lot about. Now again, whether or not those patients do any better than patients with a 2 log reduction, we don't know. But if patients do get to that 3 log reduction by the PCR test, we can confidently say they don't need another bone marrow biopsy test. And then the 4.5 log reduction is the other one to really pay attention to again, because these are those patients who have a very deep molecular remission who may be eligible for treatment discontinuation studies. One last thing that I'll just follow up on. So I do a book in the U.S. with the LLS. I sort of edit it periodically, and I don't know if that's something that could be forwarded to people in the audience for translation purposes.
Right, so we talked about the book, the guide, it's the guide, right?
I actually brought samples of both the guide and the current publication that hasn't been printed. The one you just recently reviewed has not been printed yet. But if my luggage arrives, people can see what it looks like. And then I'll provide information on the link, and yes, it can be translated.
So this is Gail, and she represents the Leukemia and Lymphoma Society of the U.S. And I have to say, she just made reference to her luggage not coming yet. And she has there some of the copies of this publication. They're really great, simple CML books for patients. And so look for Gail. Once she changed her clothes, you'll know that she got her luggage. And then you can ask her to see the booklet, and let's see if that's something that you think could be useful in your language for your countries, and then we can all work together to get that translated. Because LLS is really wonderful and generous about allowing groups to translate some of these materials that they have. So. Thank you for reminding me, because we had a lot of talk about this booklet, there's 2 different publications, right? So that's great.
One small thing, doctor?
I'm sorry?
One small thing.
Yes.
Which means, as you mentioned, that the sensitivity of the test is very important to know the treatment level. Which means the sensitivity of the test done by that lab is most important. Are these labs are following some guidelines that they have to do this test to this level or not? Have they standardized to some levels? Because if, as a patient, I am not aware whether the test being done in this lab is of that level or not, maybe that on log 2 reduction, they will say you are absolutely fine. So the sensitivity is very, very important in this case, and whether the labs are following this or not, is the question mark.
Yes, so the question of, so one issue has been standardization of results from one lab to another, and there has been a major push to try to get labs to use the same standards so that they will report their results on what is called the international scale. Because without that, if you, even in the US up until recently, if I had a patient getting a blood test for the BCR-ABL level done in my hospital's lab, or if he went to another hospital in San Francisco, we'd get two completely results reported with different units, and there would be no way of comparing the results. So the international scale is designed to at least put people so that they're reporting on the same scale. Now, whether or not they are assessing for how sensitive the test is at low levels, I don't know the answer to that, because for these discontinuation studies, what is actually being done is any patient who wishes to participate, they first have to have their results confirmed in one particular lab. So all the patients who are going to be participating in this study are going to have their sample sent to this one lab, and they will determine if they meet that threshold. So I don't think we've yet addressed that issue of testing whether or not somebody is undetectable or has a 4.5 log reduction. But in terms of the standardization with 1, 2, and 3 log reductions, yeah, there is a major movement going on throughout the world too. But the thing that you really want to see in your PCR report is reference to the international scale. And we changed the guidelines in the United States recently to demand that that's how the testing be performed. And the reason we did that in part is because we were tired of having all these labs reporting things in ways that could not be compared. And our hope had been that if we specify that in the guidelines, then insurance companies will only pay for tests that report results that way. And since we've done that, the number of tests that now report on the international scale has gone way, way up. So it seems to have worked.
So I also wanted to ask, because I am sometimes concerned with patients, this is how it goes. They go to the doctor, and the doctor looks at the result and they said, "You're fine." That's the end of the conversation. You're fine. So at the most, some doctors will say, "You're negative." Most patients don't know what kind of test was performed. Was it PCR? Was it not PCR? How sensitive was the PCR? Was it in the international scale? And so we're trying to make sure that we create some materials with what questions should patients be asking, but it would never occur to a patient to ask the doctor, because the doctor very sure of themselves said, "You're fine," or "You're negative." And so should everyone be asking? Exactly.
I think this is a very important issue, because CML is not the most common disease, as you all know, and yet we know more about it than almost any other type of cancer. And so frequently, you cannot expect, a physician who is seeing so few patients with CML to necessarily be up to date with the latest information, given how few patients he or she may be taking care of. And so there's a real opportunity, I think, for patients to really to grab hold of their own medical, of their own case to an extent, and do their own research and see and really push the physicians a little bit and say, I read online, for instance, that I should have PCR testing done, and after 3 months, I should have had this type of response. Can you show me where that has happened? Even in the US, without question, there are plenty of patients I have seen in second and third opinions whose disease is not adequately monitored. And I think one of the real tragedies about this is, of course, the tremendous amount of research that has gone into making this a disease that in most cases we hope will be one that does not in any way shorten the lifespan of people with the disease. Of course, we won't know that with certainty for decades, but that's a very reasonable hope at the present time. But if using all the information we have, if it's not getting implemented, then that, of course, is really tragic. But I do encourage, in my experience, just within a few weeks of patients being diagnosed, they can frequently educate themselves about this disease more than the first physician that they're going to see. And I think it's important to take that
Right.
responsibility, especially with this type of disease and what is at stake.
And I think it's very different in some of our countries where it doesn't occur to people to ask more questions from the doctor. The doctor tells you you're fine or you're negative or your test is fine, and it's a mindset of getting patients to even consider that maybe I should be asking more questions to my doctor because the doctor seems very sure of themselves what they're saying, right?
Yeah, and then I think the last thing that we all would be in this situation, you know, we all like hearing what we want to believe, right? And so if we go to a physician and he or she says you're doing fine, we really want to believe that. And it's hard to then say, well, are you sure I'm fine? Or, you know, why do you say I'm fine? Because otherwise you'd really want to believe it and just walk out of the office. But it's really important to move past that and get the information so you will really know and not find out down the road that you should have been asking these questions earlier.
Right. And then, yeah, Eunice, I'll let you ask your question. You have a mic? Yeah.
I wanted to ask, when you get to the 4 log and the 4.5 log, sometimes the result varies. For example, you can have 0.024, then sometimes you do it in 3 months, and then it goes 0.042. You know, just it fluctuates like that. Does that matter? Because I many times when I ask my doctor, when it fluctuates, she goes, it's okay. But, you know, just lamely looking at it, if I have a 0.02 in January, and then in April I have a 0.04, I just, you know, the mind just goes, is it going up, is it going down? So I wanted to find out what that means when it fluctuates like that.
So fluctuations with the PCR testing can happen quite commonly. In general, in most labs, a significant change is a 1 log increase. A significant increase. So if it's 0.02 to twice that, that's not 10 times high. It's only 2 times higher, and I wouldn't necessarily worry about that. But certainly follow the trend, and if you see a trend over time where there has been from one time to another a 10-fold increase, then that's concerning. Yeah. So the test, especially at lower levels, can be sensitive to quite a bit of noise, and that can cause some concern because people can say, well, does this mean the drug is no longer working? But most of the time it's just noise and nothing else.
Thank you. And I will ask one more question, hopefully the last one of this series of questions. But unless we're trying to see if we could stop the drug, is measuring at 3 logs good enough?
So it's nicer to have a more sensitive test in light of the previous question. You know, the hope is that if somebody has a deeper remission and they're maybe just beginning to lose response, we feel it would be easier to get good control of that disease when the disease burden is low. And so in that regard, having a sensitive test can allow you to identify those people earlier. but in practice, you know, I think that is quite uncommon. But yeah, I think ideally one would like to have at least a 4.5 log sensitivity for that particular.
But
reason.
how many labs in the world can actually measure to 4.5 right now? How common is it?
Honestly, I don't know, to be honest. Yeah, I don't know. I mean, it's not uncommon, I believe. It's not uncommon. Yeah, I think it's a standard that most people feel should be able to be replicated.
I think in many of the countries represented here, there is no PCR in the entire country. In some of the countries, there is no cytogenetics in the entire country. And we have, for reasons of efficiency, figured out that in many instances, bringing the gene expert, the Cepheid machine, is the easiest thing of all these things to accomplish. But it measures to 3 logs, the test that they have right now. So, you know, as advocates, we need to figure out, is that a good approach? Should we be trying to bring cytogenetics, or, you know, we should be trying to, or keep in mind that that's not the end of what we need to be doing as advocates, that there's more that can be brought to the country, right? Any other questions about this? Yes, my friend.
Yes, on the diagram, I don't understand how can level 0.032 can be lower than 0.01?
Yeah, good question. Are we missing a 0 in here? 0.032. You can see it.
Yeah. Oh, yeah. That is. You're right. There should be an extra 0 in there. Yes.
Okay.
I did not make this slide.
That means we are all understanding this. Good job. That was amazing. That's amazing. Very good. That means we're really starting to understand, and this is. I appreciate that it's a lot of information, but I think we've been taking little steps to actually get all this information. So I think we have really talked about this slide, what's all the fuss about with the PCR. And I think that's what Dr. Shaw was talking about. You know, they are now figuring out which patients will do better in the long term, and they figure out that the ones that respond very quickly, very deep, will do better in the long term, or at least that's what they're trying to figure out if that's true. So when we hear about some of these clinical trials that they will talk about in the sessions, that's what it's all about. There's a lot of different trials about if we use this first and that first, and how fast and when do we switch, you know, now that we have so many options. How do we manage? So these guidelines that we talked about have milestones. So this is what Dr. Shaw was saying, that now I think there's consensus of that 3 months, there's a milestone after 3 months of starting a drug that you want to see 1 log reduction. And if you don't, then you switch to another drug. Yeah. And not a consensus anymore of increasing the dose of the drug. People, if possible, switch to a different drug, right? So this is what the PCR is all about, and that's why we have worked so hard together in the last few years to improve access to PCR in our countries. And traditional PCR technology is very difficult. It's not so easy to bring, but there's not only Cepheid, there's many other companies that make PCR kits. There's a company that make this calibrator that you can bring to the lab. So I think there's many options for our countries. But one of the things, another advocacy note, is that all of us should know in our country what's available and what's not available, to have and be able to tell our members of our group where to go, or to work together to improve the conditions if we really need to improve in our country. And we talked about standardization, so we know that there's this need to standardize the test, and in the US, Dr. Shah is saying that there's a big effort and people are actually standardizing, but in a lot of the labs in our countries are really not standardized. And that is, I was emailing with one of the physicians from India who was saying that they want to do these trials of the stopping, but unless we have a better handle on what labs are people using, I don't know if you can even think of having a stopping trial if we don't really have good standardized labs, right? Right.
Is there any accreditation done? Suppose, for example, I know a lab which says that my result is as per international scale. Now, what kind of certification he has to sign that? He's writing that. I know the Quest Diagnostic is a US lab, I know that. And they have a branch in Delhi now, in India, and they write in their report that these results are based on international scale. But do I have anything to that please show me this certification by or something like that? I'm just asking you.
Right, right.
Why should I believe that? On what grounds?
Well,
like there is something called accreditation done.
Yeah, so your question is, I mean, I don't know that I have any way of knowing which labs are. I mean, the Quest in the U.S. is supposedly, I mean, and when they say that, I believe them, to be honest. I have to draw lines as far as what, when I'm going to doubt. But yeah, I take that at face value. I think you should too.
Exactly.
Yeah.
I'm asking what face value.
Yeah. Right. Okay. So I think we talked about this somehow, but I wanted you to be familiar with the terms. So a few years ago, when they're talking about, okay, certain patients, we stop the drug, they still remain undetectable. Is that a cure? So people were talking about a cure, but now, because it's not exactly, we believe that the disease is still there, it's just very, very, very deep, right? So instead of talking about a cure, they're using this term called treatment-free remission. So this is what you can achieve, treatment-free remission. That means that it's a remission without treatment. So you don't have treatment and you're in remission. So you'll hear that in the conversations later on. And then they're talking about eradicating CML, which is a different thing from treatment-free remission, right? It's really curing the CML. And hopefully soon we'll be here again and talking about eradication of CML. And right now, we don't know when CML is eradicated, right? It's not known, possible. Can you say that somebody has CML eradicated?
Right, so what I tell patients is I could find out if they have no evidence of disease if I looked at every cell in their body and did PCR on it, but I cannot do that and keep them alive at the same time. But part of the reason that we use this term treatment-free remission is because we have used the word cure a little bit too prematurely in the past. I mean, as I'll present an interesting case tomorrow. This is the longest I know of any patient, of a woman who stopped her imatinib more than 10 years ago and is still undetectable all these years later. Is she cured? She may be, but it's been 10 years. I cannot guarantee that after another 10 years she will continue to be in this position. And so a cure for a 30-year-old means the disease is not coming back over the next 50 years, and we just don't have that long follow-up to really say that right now. There have been studies that have looked using a very specialized research-based PCR test that can maybe get 1 log greater sensitivity, and in that test people can still document the presence of BCR-ABL in those patients. So we suspect that in most patients who stop and their disease remains undetectable, there's two possibilities, right? Once they're below that 4.5 log reduction, they're either at 0 or they're anywhere between 0 and the detectable level. And so we assumed that the vast majority of these patients are somewhere in between, and what is keeping their disease in check, we don't exactly know, but we think in some cases it may be the immune system that is controlling the disease, and that's what's allowing these people to continue to remain in remission. But this is an area that we really don't understand that well right now.
And I have to say, because as I was preparing this presentation, I was thinking of us. There's these two realities, right? So there's the research, where you have all the drugs available at any time you want and all the tests available, and we're trying to figure out how to best use them and how to stop treatment and all that. And then we have our realities where, do we have Gleevec? Do we have Gleevec without interruptions? Do we have PCR testing? So we're so way removed from that conversation that I just wanted to say the reason we want to understand this conversation is that we're hoping that all this debate will give us the guidelines, so when, maybe we'll skip 2 or 3 of the things that they're doing today because they'll figure out there's a better way later, and we can catch up at the end, meet together here, right? So if they discover a better way to measure PCR, then instead of trying to bring all these other methods, we'll go directly to that one. So this is how we, I think, are going to benefit from all the research and the conversation and the debate that they're having now. But it really is not have anything to do with the reality of treating CML in many of the countries that are represented here. So I just wanted to make sure that we acknowledge that also. So the last part, we're almost done. We have done great, I think. I'm very proud of us. And I wanted to talk a little bit about the current research. And I think we have said something about them. So there's a lot of research in how to manage all these drugs in the best possible way. There's research about quality of life going on. And research about, if you're living with CML for many years, you might have other things going on with you, have diabetes or have some heart disease, or how do these things all kind of work together and what influences what? Does the immune system or interferon have a role in controlling CML? These are some of the types of research that they're going to be talking about in the medical sessions. And I wanted to say that these trials that test some of these theories have these funny names, okay? The IRIS trial was the first original trial that compared imatinib with interferon, right? Because interferon was the treatment before there was imatinib. So that IRIS trial, you hear a lot about that trial. And then there's all these trials that I have listed here, Decision and PACE and BELA and ENEST. And I will ask Dr. Shaw, when you talk about it in the sessions today and tomorrow, if you can say what it's about, because there's people that are hearing this every day, know exactly what they're talking about, and we do not have any idea of what these trials are and all these names, and there's no way we can learn them right now. But I wanted to give them to you in the handout for you to sort of become familiar with these tests. There is even more. I hear about this TIGER and the STEAM and the STOP and the Euroski and all these different trials that most of us do not know what these are. So we do need just a little bit of slowing down during the sessions to explain to us, just give us a little context before you talk about different trials, okay? And then I think this is hopefully the last slide, but I wanted you to know there are some really helpful resources. We talked about the LLS materials, but the CML Advocates website, which should be a website you're familiar with, has a lot of materials for you. Every year, one of the big conferences with the new data is presented is this ASH conference, is the American Society of Hematology meeting that happens in December of every year. And some of the advocates go there. Jan and Giora are always there. And Jan puts out this really great report of all the new data that he saw presented. And he writes this report and he puts it here. And some of us help translate to our languages. So this is something also that you can look into these ASH reports if you want to know what is it that the doctors are finding out, the new data that is coming out. And also, CML Advocates is trying to start a CML trial registry. So we hear about all these clinical trials, and we want to know, are they in our country? And where is the closest clinical trial, maybe about some new drug or something? So CML Advocates is trying to keep sort of an unofficial registry of all the trials so that you can go to one place and see all the different clinical trials that are happening at one moment. So I think that this is very good. Whoops, don't know how that happened. But anyway, all it said, that last slide, was that there were things we didn't talk about. We didn't talk about phases of CML and what does that mean, accelerated or chronic phase. We didn't talk about how to read a PCR result. And I don't know if there's anything else or any other questions. We have about 10 minutes if anybody has any more questions for Dr. Shah. Yes.
No, for you, Pat. I'm Rod from the Philippines. I'd like to thank you, Pat, for a very extensive 101 session. We might as well call it CML 201 or CML 202. I've been attending CML Horizons even when it was still New Horizons at that time, and I learned what I know now through the years. I think it is expected that your slides will generate more questions, needing more detailed answers, but basically you covered everything there is to know, from the simple to the very complicated, in 2 hours. I saw many are taking down notes. Some of your line items in your slides are actually big topics by themselves. Just a short logistics question. Is your presentation, as well as the other presentations in the next 3 days, downloadable from the CML Horizons website so we can cascade the information to our members back home?
Thank you, Rod. You can tell he's my friend. It's a nice feedback. It's actually being videotaped, and the video of the presentation will be available in the CML Advocates website.
How about the slides?
I'm sure that we can put the slides. I have to check with Jan and Giora, but I'm sure that I will give you my slides. I don't mind at all.
But I must appreciate, Pat, you have set the mind what we need to learn.
Right.
This has given us the path how to go about in next 3 days. Trust me, it's very, very useful.
Right. So here's what I want to ask from you. Here's what I really want to know. After all the medical sessions, did you think that this was useful? And because we have not had a session like this before, and we have to figure out, after you hear all the things you're going to hear, if you can catch something like, oh, I remember we talked about that in that session. So that is what we really need to know. Did we hit the spot with the amount of information to give?
One is Bible and one is how to read the Bible. So this is how to read this next 3 days.
Right. Good. Yes, Ka.
Hello, Pat. I'm Ka from Cambodia. Earlier, you mentioned about cause of CML. You said CML patients don't pass the diagnosis to their children. Is it sure, like 100%, that the CML patient don't pass it to their children? Because like some of my patients, my group member, they keep asking about it.
Right.
I've had a few women who were diagnosed during pregnancy with CML, and of course they're the ones who are most concerned that maybe some of their leukemia cells were passed on to their children, and some of them have just for their own peace of mind wanted their children to be tested by PCR, and they've always tested negative. So I'm not aware of any concern that you can transmit the disease as a pregnant mother, and similarly, if anybody has CML, their relatives are at no higher risk of developing the disease than the general population. There are rare people who will have CML and they'll say, my mother or my father had CML, but we just think that's, one in, I don't know. If you think about the numbers, if 1 in 100,000 people is diagnosed with CML every year, and if we live to be 100, let's say, that's an overestimation, but that means that each of us has maybe a 1 in 1,000 chance within our lifetimes that we will develop CML. So then you could say that maybe approximately 1 out of every 1,000 or 1 out of every 2,000 CML patients may have a parent who also had CML.
I have one more question. As you know that CML patient, for the female, because I am a CML patient, we cannot like get pregnant because we take the medicine, right? So it's like we cannot have children, right? And how about the female, like a male CML patient? Like as you said, like we cannot transfer it to the children. So is it the same, right?
So yeah, that's a very important issue. So as the disease has gotten better managed, 20 years ago, the prognosis, as you probably know, for a CML patient was not so good. And so younger people who were diagnosed, if they didn't have kids, they just figured, well, I may not be alive even long enough to raise children, so I won't even bother trying. But now, as I said, it's very reasonable to expect that a younger person diagnosed with chronic phase CML, that the odds are, from what we can gather to date, the odds are very good that that person will live to be however old they would have been even if they were never diagnosed with CML. And so many younger people are then saying, well, I'd like to then have as normal of a life as possible. And with men who have CML, who take these drugs, we don't have much information, but the information that is available does not suggest that there's any clear risk to taking the drug as far as, so I'm not talking about passing the disease on now, I'm talking about risks of taking the drug on fathering or mothering a child. So in the case of a man who's on one of these drugs, so far the data are really quite reassuring. I have a number of men who have had CML for years who are now having children, and they seem to be healthy children. With women, it's not quite so clear cut. So with women, we have the most data available from women who've been exposed to Gleevec during pregnancy. It's not a lot of cases, but what's been reported, at least to date, has been on the order of between 1 and 200 women who became pregnant while taking Gleevec, or they took Gleevec at some point during their pregnancy. And 50% of the known pregnancy outcomes were actually normal, healthy children. Now, the other 50% were a mixture of miscarriages. I mean, in any healthy population, there's going to be some miscarriages. There were some women who chose to terminate the pregnancy because they did not they didn't want the pregnancy from the beginning. And then there were some who were born with some birth defects. Now, again, of course, even in the normal population, birth defects can occur. But nonetheless, because there were some of these birth defects, we usually are just as we're very cautious with using the word cure, we're very cautious with using the word it's safe for a woman to take this during pregnancy. So we sometimes go to the other extreme and say it's not safe for you to have a child. But in practice, I have, in fact, the patient that I was alluding to earlier, who's unfortunately one of the 1% whose disease I cannot track by PCR, she really wants to become pregnant. And so that's posed a separate issue with how do I, have her, maybe interrupt therapy. But that's one of the reasons that, if people get to where they're in a very deep molecular response, at least a major molecular response, preferably a 4.5 response, so their disease is not detectable at that level. What we are doing in some instances is saying, if women wish to try for 6 months or so to become pregnant, and if they do succeed, we can continue to monitor their disease. If their disease starts to come back up, then the question is, well, what do you do if they're pregnant and their disease is coming back? And we think interferon is safe to be given during pregnancy. So in women who want no risk to the fetus, that's something we can do. We think that beyond the first trimester, hydroxyurea is safe if necessary, if the white blood cell count goes high. And even the kinase inhibitors may be safe after the first trimester, but again, we're very cautious to use this term. I'll just give you one, I think, rather remarkable case story. So there's a woman at my institution who was diagnosed, I think when she was 16 or 17, with CML. And she was started on imatinib and had a very deep remission, but she was never undetectable. So she convinced my colleague that she wanted to be cured of this, and this is many years ago when we knew bone marrow transplant, and we still know bone marrow transplant can be curative, but she talked my colleague into giving her a bone marrow transplant, and even though she was in a very deep molecular remission. So she had the bone marrow transplant, and no complications, thankfully. She was told, though, if she has this bone marrow transplant, there's a very good chance that she won't be able to have children because of the therapy involved with the bone marrow transplant. Unfortunately, her PCR test did not go any lower, so she went through the whole process, and she still had a low level of BCR-ABL still present. She then went on to dasatinib, and then went into negative, and she's remained negative or undetectable since then. But about 6 months after starting dasatinib, she went to a local emergency room complaining of nausea and vomiting and abdominal pain, and she was asked, is it possible you could be pregnant? She said, no, my periods never started. I was told after the transplant there's a good chance I may never have kids again. So they did a CAT scan, a CT scan, and the radiation, right, of a CT scan, and they saw a fetus, okay? And she had been taking dasatinib this whole time, and at that point, she was probably already even past the first trimester. And so my colleague who was taking care of her said, well, why don't you just continue your dasatinib, because if any damage that may occur has probably already been done. And so she took dasatinib throughout her pregnancy. She had had a prior bone marrow transplant. She had had the radiation of the CAT scan, and she had a normal, healthy child. Now, I'm not saying that that means that it's safe, but I'm saying that there are risks to this, but I don't think, if having a child is something that is extremely important to you, as long as you understand the risks involved, there are risks involved to you as the patient if you decide to interrupt therapy. There are risks involved to the baby if you decide to continue therapy. There are risks involved either way, But as long as people are reasonably comfortable, I think it's something, I wouldn't say that it's absolutely impossible, certainly.
That was a nice story. Thank you so much.
Sure, sure.
Anything else? Good. We have 13 seconds left from our session. So thank you very much for all the attention, all the questions. I'm really happy. I think we had a great dialogue. I'm very grateful for Dr. Shah to be here and answer our questions. And now you all know him, so you can find him at lunches and dinners and follow him around and ask him more questions. So I guess nobody told me anything of what's happening next in the program, but oh, lunch, perfect. So I guess we're gonna go have lunch and then start the conference. Thank you.